In this video, we're going to talk about extended access lists. Now, in a prior video, we talked about standard access lists. And when we talked about them, we said, well, basically, it's just a list of rules. You write out a list of rules, and then you look to see if something is either approved or denied based on those rules. Those rules are applied in an order. Normally, it's referred to as a top-down order. Basically, you start looking at the top of the list, and then whether something is approved or denied, you just start at the top, and then you keep working your way down. The first rule to win, to match with the traffic, is what wins. I always try to think of this as a teacher in elementary school. Had a teacher in elementary school who would say, okay, class is dismissed except for Ed. Now, I don't know about you, but I heard class is dismissed. I didn't hear except for Ed, because the first rule, the first thing I heard was class is dismissed. So the order of the rules actually matters. If the teacher had said everybody except for Ed is dismissed, then that would have been a little bit more clear of, hey, you stay in your seat because you're in trouble because you did something wrong, but then everybody else can go. So the order is very, very important when you're applying these rules. And then lastly, there's an implicit deny at the end. And this is oftentimes a really hard one for everybody, whether you're a seasoned engineer or brand new to the idea of firewalls, is that there is a deny at the end, which means a lot of the rules that you create, a lot of these rules up here are going to be permit rules. With the exception of when you say, okay, Ed, stay in your seat, everybody else can go, you're going to be doing pretty much just permit rules. You're going to say everybody can go 99% of the time, and then you just have an implicit deny of, if I'm not in the room, if the teacher's not in the room, you can't be in the room, kind of rules happening. Standard access lists. Additionally, they only look at the source address. So here we have an IP header, and it's only this one little piece of information that is inspected with the standard access lists. And why would you do that? Why would you only look at one little piece of the IP header? Well, really, because it's very low overhead. Remember, computers are not very smart, and until recently, they were really, really slow. So the idea of looking at more than just the IP header, looking at more than just the source IP address, was very compute intensive and would slow down a lot of the traffic. So what they did was they said, hey, you know what? We're only going to look at the source address. We're only going to look to see who's sending us this traffic and then decide whether we want to allow it or not. And then lastly, yes, we can apply this to an interface and a direction. One thing to note here is you only have one rule per interface / direction. So if you have interface 1 and you create an inbound rule, you can't have a second rule for interface 1 inbound. You have one access list, one list of rules per interface and direction. Okay, well, if that's a standard access list, well, before we dive into the extended access lists, let's look a little bit more detail of what we're actually dealing with here. And specifically, here we have the TCP IP header. We have the IP header, and we were previously looking at only the source IP address. But there's a lot of other information here that we can look at when we're dealing with our firewall rules. And now that computers and processors are more powerful and do this in real time. So we previously were looking only at the source IP because that was the quickest and easiest. And quite honestly, that the source IP comes first before the destination address. So if you're only going to look at one, it would make sense to look at the source because that's the first part of the packet. Therefore, you only have to read into memory this portion into the memory in order to inspect it. Therefore, it makes it a whole lot easier for the router or firewall or switch or whatever access device you're using. But there is a whole lot more stuff here. There's the destination address that we can look at. There's the source and destination ports that we can look at. There's even the protocol right here of TCP versus UDP versus IGMP versus whatever other protocols we might want to look at. So there's a lot more information that we can start looking at here that we can start applying our access lists on. And this is where the extended access lists start coming in. So the standard access list filters on the source port only. Like we just said, source port only, that's source IP only, excuse me. And then historically has been normally placed closest to the destination. And the reasoning there is that if you have, 100 different sources coming to you, you want to be able to have one location that you can manage all of those. And so you would put them on normally the device closest to you so that you could filter out the sources appropriately. This is considered a best practice, but it's general. Extended access lists, however, can start filtering on more than just that. Like we just said, well, there's the source IP, there's the destination IP, like we saw was right next to the source. Why shouldn't we be able to filter on that? When we're talking about TCP and UDP, we're able to filter based on the source and destination ports, and then also the protocols. IP, TCP, UDP, IGMP, ICMP, EIGRP, OSPF. There's all kinds of different protocols that we can filter on. These source and destination ports will change if it's a OSPF instead of a TCP. The features for those change a little bit, but it's still essentially the same thing. These guys right here are normally what's referred to as the 5 tuples in firewalls. I hope I'm saying that right, tuples. I've heard it both ways. I think it's tuple. But basically you have 5 sets of rules, 5 items that you can filter against, and you can set these up in an AND formation. So you can set up a rule that says the source IP and the destination IP and the source port and the destination port and the protocol all have to match for a rule to be applied. Now, because you can filter on both the source and the destination in this case, this is normally applied closest to the source of the packets. Again, that's a general rule of thumb. It is not always the situation. Well, let's take a look at what this actually means in real life. Here I have a network diagram. Very, very basic. I have a client out here that's out on the internet. So if this is the internet, I then have a router with 2 interfaces, G0, G1, and then 3 different servers. Now let's say that I want this client to be able to reach this web server out here. Well, if we follow the network traffic, if we just kind of draw out what's going to happen here, traffic is going to go kind of like this. It's a web server, so it's probably going to be on port 80 or 443. I'm keeping it simple here. I'm just saying 80. So that's the traffic method. This is going to be my source. This is going to be my destination. And then the destination port is going to be 80. But the source port is questionable. So the way the TCP traffic and UDP traffic and how ports are chosen overall, the destination, in this case from the client to the server, is going to be port 80. It's going to be consistently talking to a service on the web server, so it's going to be port 80. But the source port can be anything. In this case, it is anything. It's a random number that is greater than 1024. It's randomly chosen as part of the protocol. So we have down here a table, and we're going to go ahead and fill out that table with this information. So we're going to start off with permit deny. Well, in this case, we want to allow this client, in fact, all clients. We're going to allow all clients on the internet to be able to access this web server. So our permit deny, we're going to permit. The source IP, we're going to put a star in there. This is just a wildcard. In many firewalls or other access lists, you're going to type in an any right here. I like typing a star just because it's really easy. So in this case, any source, any client with any source IP address, since the source port is going to be randomly generated, we can't necessarily restrict based on what that is. And then we're going to have a destination IP of 10.52.16.5, which is our web server, and a destination port of 80. Awesome. Okay. Protocol is TCP, not UDP. And then which interface do I want to put this on? Well, I've got G0 and I've got G1. We said the rule of thumb was that we wanted it to be the closest to the source. G0 is closest. I mean, that's for lack of a better choice. I mean, I'm just choosing G0 because it's a little bit closer than G1. So I'm going to put it on G1. And then which direction is the traffic going? Well, the traffic is going that way. So from the router's point of view, this is inbound to the router. So therefore, it is an inbound traffic direction. All right. Well, hey, that's pretty simple. Let's do the mail server. Well, pretty much the same thing. Mail server, mail runs on port 25 for SMTP. So I'm going to have inbound from anywhere on the internet to the destination IP 10.52.16.7, destination port of 25, again, protocol TCP, and then the direction is G0 and the direction is inbound. All right, let's do the same for the FTP server. FTP server is port 21. So same kind of rule. Source of any, source port of any, destination IP .8, destination port 21, protocol TCP, and then the interface is G0. So that's the majority of the traffic that I was looking at here on my DMZ. Let's say I want to add a little bit of troubleshooting capabilities. Let's say I want to allow ping. Now, from a security standpoint, this is not always the best thing to allow. If somebody can ping your routers or ping your devices, then they know there's something there, and it allows them to attack them just a little bit easier. But maybe I want to allow ping to come through. So I would do a similar rule, except this time it's coming inbound. It's going to all of those destinations. So in this case, my destination, my source was already all, or a wildcard. Here, my destination is also going to be an all. But the one thing that's really going to change is the fact that I'm using ping instead of TCP. So that's a different protocol. And we can see right there, we have a source IP star, destination IP star, and then the protocol here is Icmp instead of TCP or UDP that we might also be used to. Now, I here said the source and destination ports are wildcards. However, with Icmp, there are different types of Icmp traffic. For instance, there's an echo reply. There's an echo respond. There's a couple of different types, such as not available. I don't know. There's a whole bunch of different Icmp protocol types or traffic types that can be filtered on here with regards to the source and the destination. Just to make this example really simple, I said any Icmp type, but you may actually want to limit that down in the future, at which point you would have put those in the source and the destination port. It's not exactly a port, but it's the same kind of idea. All right, and then let's do one last example. Let's say that this guy right here, let's say that this is a management workstation. For instance, let's say that this right here, this is my corporate DMZ. And this guy, this management workstation is my home PC. Now, there's situations where I, from home, need to go in and do stuff from work, but I don't necessarily want to drive into work because, it's like half hour, maybe an hour and a half away. So what I want to do is I want to set a firewall rule that allows my home PC to be able to access the DMZ servers. Now, this is not a good way to do it, but it is entirely possible. in this case, what I want to do is I want to create a new rule, and I want to specifically specify this IP as the source, and then it comes in with a destination of pretty much any or all IP addresses on the destination hosts. And so that's this next rule right here. So you can see we have both the source IP and the destination IP. In fact, we can actually tie these together. Maybe I didn't want all the hosts. Maybe I wanted to type in some specific hosts in here. Maybe I wanted to specify some ports. I could have put in more information in here in order to further lock it down. But this is one way to start restricting access to your host based on source IP as well as destination IP. 99% of the traffic you do is going to be under this scenario right here, where it's 99% of internet-facing traffic. Let me put it that way. 99% of internet-facing traffic is going to be of that model, where the source IP and source port is just kind of open up to everybody. You may start putting in some exceptions up here, so a few denies when people start hacking you, and you may deny specific IPs. Or even entire countries, depending on what you're doing and what kind of traffic you're seeing hit your systems. So there you go. That's one example of an extended access list. In order to keep all of this information easy to see, I normally want to put some sort of a name around here. So I create a name, and I keep it in this table format, and I call it access DMZ. Therefore, when I create this rule on my firewall or on my router or on my network device, I'm able to call it access DMZ. I'm able to look at my spreadsheet and see, oh, this is what should be allowed. I'm able to look at my router and say, yep, that's exactly what's in there. That's exactly how it's configured. And then I know for certain everything's the way it should be. Now, I could have been more explicit with this configuration. For instance, on this very first rule, I said, okay, I want inbound up to my web server port 80. Now, the web server is going to talk back to me. The web server is going to talk back to the client. Once the first communication comes in, he's going to respond back, and he's going to respond back on some port that is greater than 1024. So I could have created a second rule in here that allowed traffic from my web server back out to the internet, and I probably should to some degree. However, that can oftentimes be very, very difficult because, well, pretty much anything greater than between 1024 to 65,534, I believe, 655, I want to say it's 35. Anywhere between those two ports could be the return traffic, unless I more explicitly block or lock down which return ports are available from my web server. Anyway, it can become very problematic to be able to start restricting the return traffic, especially when you're talking something like a web server. Locking down the return traffic is only really helpful when you're in kind of a more controlled environment, such as an internal network that you're restricting traffic back and forth. With that being said, yeah, you normally only want to restrict one direction, not both directions, unless you know explicitly what you're doing. All right, a little bit more detail about that. Actually, let's talk about the TCP Three-Way Handshake. So I found this image online. Says it's a common, available for a common license. So hopefully I won't get in trouble for using this. But here we have an example of a client. Let's say this is just a web client, and then out here we have a web server. And so the TCP Handshake, if you're not super familiar with it, you'll get more familiar with it now. Basically, it works on a SYN-ACK type scenario. What happens is the client sends a SYN or a synchronous message to the server. Since the web server since this is a web server, this would be sent across port 80 or 443 if you're using SSL. But in this case, we'll just talk 80. So it sends the SYN request across port 80. The web server responds back with something that is greater than 1024. Let's just choose a random number here. In fact, I'm going to go so random. I'm going to say it responds back on port 1025. That's greater than 1024, right? The client then responds back and, so it sends back a SYN and an ACK, an acknowledgement of its synchronous request, and then another synchronous request back to the client. And then the client finally responds back with another ACK on port 80. Think of this as a phone call. You're calling up your mom, you say hello, your mom says, hi there, how are you? And then you respond back, I'm doing great, thanks. Right. Yeah. TCP Three-Way Handshake, and this is where you really have to know what traffic or what direction your traffic is flowing in. If I want to permit or deny, if I want to control the traffic for the web server, specifically web traffic, then that means I need to control the traffic going that way on port 80. I could try to control it going back on a different port. However, if I try to control it going back on port 80, well, I don't have any traffic going back on port 80. All the traffic I have is actually right here. If this is all my traffic and I try to control what's going back to the client on port 80, I'm never actually going to hit those rules. So this rule will never take effect, and therefore the client will never get any communication to the web server. So you have to be a little bit cautious about which direction the traffic is happening and which way your firewall rules or your access lists are being applied. Additionally, let's see. So say you have two rules. Here's where we have the situation of trying to apply rules on both directions. So let's say I have an inbound rule. Inbound. For port 80. Port 80 permit. And then I also have an outbound rule, a rule that goes back out to the client on port 80 and permit. Now the first rule, allowing port 80 in, that's going to go right through. But because the return traffic is coming back on a port that is not port 80, then this outbound port 80 permit is never going to be hit, and therefore the client will keep requesting communication with the web server. The web server will try to respond, but the firewall will block it. So extended access lists give you a lot more capabilities. They give you a lot more features, a lot more abilities that you didn't have before. Try to take these slow and try to plan out exactly what you're doing before you actually do it, because these additional features can start getting you into trouble if you're not exactly sure how they're working. Basically, yeah, go slow, come back to the prior page right here. Come back to this list down here. That list is the most important aspect of trying to plan out what you're doing prior to actually doing it, and then finally implement it when you're done. So that's an intro to extended access lists. You'll definitely get more understanding of them as you get in and start implementing them and practicing with them. It's really one of those things where once you start working with it, you start realizing exactly how useful this spreadsheet is and how to best implement the rules.